Okay, my outstanding friends, prepare yourself. This is PBS space-time. What if the speed of light is not constant? I've been bombarding them with saying the speed of light isn't constant. We don't know where we are in the universe, all this stuff. Now listen to what he has to say. And again, this is PBS system. Now here's what he has to say about missing some of the comments.
Few comment responses recently. Actually, we missed 6. It's my fault. There's been a lot going on, including too much trouble. And these responses actually take a lot of thought on account of your really, really good questions. So today, we're going to go back and do responses for a selection of the missed episodes.
All right. The selection he did has nothing to do with the speed of light. Now, I'm going to show you my evidence, and then we're going to get into what he claims, all in a big mix. Here it comes. Okay, my outstanding friends, get ready for the biggest shocker of your life. What if the speed of light is not constant? Every single thing in physics, in astrophysics and all that, is based on the speed of light being exactly a certain speed, never changes. Well, that's just not true. So I claim that the speed of light is not consistent, and here is my proof. This is light, pulsed red laser. And what does that mean? Bip, 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 bip. A beam comes across, and there is a particle inside that creates a disturbance called a wave. The disturbance is the particle's field, which is a magnetic field, has to push through all these other particles in space, in the light, in the air, and they are also magnetic, and they have to push and shove. This pushes, these shove back. These glow, this glows a lot because it's coming through the air. Now, it's got to push everything apart. That looks like it's staying basically the same speed, although it is beginning to accelerate because we have a Venturi, and here this is what happens. Now it's in full acceleration mode. Now that's not staying the same speed. There's no question whatsoever. Absolutely undeniable that is accelerating. There is nobody on the face of the planet that can deny that. Just out of hands. Oh, no, just nothing. No, it isn't. It's a particle in the wave, and now the particle is accelerating out of the wave. That's acceleration, my friends. Now, what is this? This is slowing down. This particle is coming in very, very fast, and it's almost in a straight line, and then it starts to drift off as it slows down, and it's drifting off. It's spinning to the right, drifting to the left. That's the case. This is obviously not the same speed as this, so I don't care how you look at it. It's either speeding up or slowing down. It's obviously slowing down. That direction is slow. This is fast. Here's blue going through glass. It's obviously slowing down. This is where it's going, and then it's starting to slow down. It's bang, boom, bang, boom, bang, boom, bang, boom. And here it's and it's slowing down as it accelerates out. It takes its path out through the glass. Now, what is all this stuff? These are all the little tiny electrons that are in the gases that this field has to force its way through. And those electrons get excited and they glow. That's what excitation is glow. And we got glow on steroids. You see that? This is extreme increase in energy from where it was here. This is literally a subatomic nuclear explosion. The particles divided. It's called fission and fusion, and here it is right here. They came in as the two particles, the black and white balls. They're called electron and neutron, muon neutrinos. When they hit another medium, they separate. The muon goes all by itself, the black, and the white goes into shower. This is the holy grail of energy right here. And, it's being denied because of this Einstein nonsense where you can't speed up, you can't slow down, we have to follow those rules. No, those rules do not apply because they were wrong. They were wrong from the day one. They're still wrong today. light accelerates, it slows down. Have no idea right now. We have no idea whatsoever where things are in space, because as they come through space, if they come through a thicker medium, they slow down faster. If they come through just almost a complete vacuum, they just almost continuously go the same speed. I agree with that. But there is no such thing as a vacuum in space. None whatsoever. There is no vacuum anywhere. Space is saturated with particles called the quantum foam. Now don't forget, 100% of physics is based on light going through this mess and staying the same speed, which is absolutely ludicrous to think that that's even the slightest bit possible. And that's just that's a law. Now this guy, finally, I've been after him for years now, saying, oh, I've got all these light experiments. Now this just came out a couple days ago, 2 days ago. And came out 2 days ago. And he's saying, now he's questioning it. Thank God, finally. Now this is PBS Space-Time. He's got 2.9 million subscribers. So let's see what he has to say.
One of the most fundamental physics facts is that the speed of light in a vacuum is constant for all observers. But can we really be sure that the speed of light wasn't different in the past, or perhaps in other parts of the universe?
It doesn't have to be different in the past, or it is different in every single different place in the universe, yes. Okay, so I've just shown you Einstein is wrong. Light speeds up, it slows down. It has to navigate its way through all this debris that's in space. It's slowing down very, very fast. And instead, they say it doesn't slow down at all, continuously, never changes speed, which I just showed you that's just not correct whatsoever. Now, I've been after these people for years. PBS Space-Time, which is public broadcast system, and they got 2.9 million subscribers. Let's talk to me. I said, please, let me show you my information. I've never heard word back, but I've never heard from anybody. So let's see what he has to say about the speed of light and what difference would it make if it wasn't the same, if it wasn't constant. First of all, we know that we'd have no idea where all these things are in space. If this thing's coming to us at half the speed of light and we think it's twice as far away, because, same thing with all of that stuff. And the denser the area is, the more interaction and slowing down the light will happen. The more vacuum-ish area, and there is no vacuum, none, zero, anywhere in space, none. Every place in space is saturated with the light particles, which I just showed you are particles. They're not nothing. So those particles have to be pushed through, and that's what slows down light. Now let's see what he has to say about what if it was wrong. Listen to this. Here goes.
One of the most fundamental physics facts is that the speed of light in a vacuum is constant for all observers.
Did you see what he said? One of the most fundamental facts. A fact. That the speed of light in a vacuum is constant for all. Well, in a vacuum, possibly. There is no vacuum.
But can we really be sure that the speed of light wasn't different in the past, or perhaps in other parts of the universe? In fact, variable speed of light theories have long been used to try to explain everything from dark energy to gravity itself.
And I have done that. Dark matter, dark energy, gravity is the muon, which is the black particle, shown it over and over and over again. And I have explained it. And now I need somebody to say, no, Roger, you're wrong, and here's why. And they have refused to engage. So it's very hard to get your point out when nobody will talk.
So let's explore how constant this fundamental constant really is.
It's not constant at all, my friend. No consistency there whatsoever.
Speed is relative. Drop your smoothie on a train and it appears to fall straight down, but to me, standing on the platform, the smoothie falls diagonally, apparently boosted by the speed of the train. But shine a laser beam from that train and everyone observes the same speed.
No, not correct whatsoever. Absolutely not correct. Everyone might observe the same speed coming at them at a certain distance, but it's going to be faster here and it's going to be slower out there. No question whatsoever. I have shown that. They're showing lasers. I'll show you lasers. Here's the lasers that I can show. And here they are. There's the laser beam right there. There's the laser beam right here. There's the laser beam right here. And they don't realize that the dark particles can be separated from the white particles. They have seen the dark and the white, but all they see them is in debris. Here's what they see when they smash these protons and neutrons together. Big, huge piles of garbage. That is a photon. And then that can break apart and make muons and electron neutrinos. They can see this. They just have no idea where it came from because they just have a particle zoo. We have the actual particles. And there's the particle right there. That's red. It's coming in as neutrinos. They change flavors as they go along until they divide at the Venturi. And here's the green doing exactly the same thing. Here's the neutrinos of the green, and here's the photons of the green. It's just a much faster particle spinning. And the blue is much faster than that. It's bzzz. You can hardly tell that there's two white particles attached until you get down here where it's starting to slow down. Over here, it looks just like one. But down here, as it slows down, you can tell there's two white particles in that photon. Before, you couldn't tell that. Now, I've shown you light accelerate. I've shown you light slow down. I've shown you light plowing through a glass. And what happens is in the air, it does the same thing as in glass, as in water, as in the atmosphere, as in the non-vacuum of space. Particles bang, boom, 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 and they slow down as they come. That means the light coming to us has not shifted red because everything is pulling away. It's shifted red because it's slowing down. Very, very simple, but because of Einstein's law, that light can't slow down, which is absolutely wrong and not true whatsoever. We've been locked into this forced dogma that nothing slows down. That's why we know how far away everything is in the galaxy. We have no idea. None. Zero. I mean less than zero. Okay, back to PBS and what if light is not constant? And it isn't constant. And this is the only way I have to show is to interact with what they are claiming. This is called the Fair Use Act, and it's here to explain the reality, what I consider to be the reality of these light particles. Now, they have to make their claims, and I will make my claims. I'm showing my claims. He's showing a little thing saying, oh, this is the same speed everywhere. No matter where you are, same speed. No, it's not true.
299,792,458 meters per second in a vacuum. No matter their relative speeds. The invariance of the speed of light is more precise.
Does this look like a vacuum to you? Does that look like a vacuum? This is insanity. How they can just make these declarations and know for 100% fact that they're wrong. And it just doesn't matter. Science is just completely broken.
It's described by something called Lorentz invariance. And it's the founding axiom of special relativity. Einstein realized that our measurements of distance and time have to be relative to the observer. They have to shift to keep the speed of light the same for everyone. This same axiom is also fun.
See, there's the law again. Oh, it has to be the same for everybody. It doesn't matter. Now we're just shifting the time, and we're shifting all these nonsense things to fulfill Einstein's dogma that light doesn't slow down. It's just wrong. Let's go back here again and see the Lorentz invariance. All right, it's named after Dutch physicist Lorentz. It is an equivalence of observation. So they're just saying no matter where you are, light goes the same speed. It's just not true.
Variance. And it's the founding axiom of special relativity. Einstein realized that our measurements of distance and time have to be relative to the observer. They have to shift to keep the speed of light the same for everyone.
The speed of light just isn't right.
Same axiom is also fundamental to general relativity, in which gravity is interpreted as a warping of the fabric of space-time.
There is no warping of the fabric of space-time. There is pulling of particles into the dark matter. It is the attractor. It is the center of matter. Matter accumulates around the dark holes.
Both special and general relativity have been tested with extreme care and precision over and have never failed.
It's never failed. It's never been right once. It's never been right.
More to the point, the speed of light has been measured in different reference frames, and its invariance holds down to the exquisite precision of current methods.
That's insanity. How can you say that, my friend? You need to see my research, and then let's talk about that.
Said we scientists are supposed to remain simultaneously skeptical and open-minded, somehow applying both mindsets to both old and new theories. So, in that spirit, let's ask whether the speed of light is really invariant. For example, could it change over time or be different in different parts of the universe?
All right, let's just take that. It changes instantly. It slows down very, very fast. And yes, it is different in every different part of the universe, because every part of the universe is either more or less saturated with particles. And every single square inch of the universe is saturated with at least photons. Now, there's also dust. There's all kinds of fragmentary pieces of atoms, which are isotopes and neutrinos and bits and chunks of matter, dust and so forth. It's everywhere. Here it is right there. There is no such thing as nothing. It doesn't exist. There is no vacuum. Instead, there is quantum foam. Very, very simple. We can see it and we know it's there. Okay, my friends, this is Fermilab, and this is Don Lincoln, who I had engaged with right around this time, showing him that we had found the particles he was looking for. Now listen to what he has to say.
16 or so. We scientists are incredibly interested in the outcome of this experiment, as it may lead to a new and better understanding of the universe. However, even with this exciting discrepancy, we must not lose sight of the fact that the agreement between the predicted and measured strength of these subatomic magnets is spectacularly good. This agreement, combined with the observed Casimir effect, gives incredible confidence in the quantum foam. And the idea of the quantum foam leads to an entirely new paradigm, a completely different way of thinking about space. Empty space isn't empty.
Exactly, Don. And that's why light slows down. You cannot have the consistency of light in this quantum foam. These fields suppress the particles coming through them because they have fields. They bounce against each other and slow down very quickly. All right, so here's what Fermilab and the rest of them do. Smash huge things and get just a zoo of particles. We started with this right here, light. That's light right there, photons. And I can prove it. Here's what Don Lincoln showed. They can see these two particles. They know they're there, and they know that one's just a solid, he called it a fixed particle, and this one is a point particle. It has no mass and all the burn. That has all the mass and no burn, basically. Very, very tiny amount of mass here, and almost all mass. And this is gravity, and it is also dark matter. They call it a muon. They come together attached as light. Half of light is what we would always consider an electron, just one glowy part. Nobody's ever seen the black part before. And the only way you can see the black is if you can let it lay on top of the white in this foam, which we did. Here it is right there. That's the only way you can see that black. You're never going to see the black unless you can get the white behind it and the black on front of it so that it obscures the white. Otherwise, it sucks the white right in. It's gravity. Everything there is coated with the white stuff, which bounces back at you. It's like a spring. It's like whenever you look at something, it hits a particle, the particle hits and bounces back at you. Now, it depends on how strong the light is. You see this? And how hard the thing is hitting. If it's hitting something real puffy, it just goes woof and bounces back real slow. Hits something hard, it goes boing and bounces back hard. It's not hard concept to understand. And this is the particle spinning through here. And the reason you see them going this way and that way is this is a single slit, not a double slit. It's because the light goes that way sometimes, it comes over the top and goes this way sometimes. But when it gets through this side, They do not want to be next to each other, and they will create these interference patterns. The white always pushes white away. There is no white next to white in a happy zone. They hate each other. The black particles suck everything right together. Everything comes in, and that's why it's gravity. And this is fission, and that is fusion. This is the holy grail, and we're down into the electronics where we're not giving off these huge atomic particles, which is what they do. So they can create these showers, yes, but in addition to those showers, they create hand grenades and bombs, and cruise missiles, and all kinds of things come out of these explosions. They do. With us, it's just light. All we're doing is splitting the two particles apart, these two right here, and then they instantly come back together. But if we can get in between here, right in here, that's a whole different story, my friend. And that is what I wanted to try to get Fermilab to look at, so we could get some free energy and get some benefit out of all these billions and billions of dollars they're spending. Refuse to look at it. Absolutely refuse. All we did was take a laser, pulse. The black can't get through. Only the white can get through, as is seen right here. The black can't get through. So it has to, the white can just push right down, because that's all you do is take the white when you charge a battery. All right, when you charge your battery up, it doesn't start weighing 100 pounds more. It almost weighs exactly the same. It's because that has no mass whatsoever, exactly what Don Lincoln said. This the white particle has virtually no mass and is all the electric energy. Basically, it's everything of electricity is done with this particle. This is the attractor or the pusher. It does both things. When light goes shining out, it pushes. When everything's stationary, it attracts. And I can prove this very, very easily. See, here's Sabine Hausfelder. What's going wrong in particle physics? This is why I lost faith in physics. They're all jumping off, except Don. We know exactly what we're doing. Fermilab, bosons. He's into this deep, and he just doesn't understand it and refuses to discuss. Now, is Fermilab spending our money wisely? I don't think so. What is good particle physics? I don't think so. It's not there. Okay, so once again, this is Don Lincoln spending billions and billions and billions of our dollars, and told me he refuses to spend 1 minute looking at anything that I have to present, which is more than they can present on their end. So he's afraid to look at it. That's my opinion. Here's what he has to say. And he's told me I won't spend 1 minute looking at your stuff. And this has been going on 7 or 8 years now.
I give lots of public lectures on various topics in physics, from quarks to the cosmos, so to speak, and I really enjoy doing it. One of the most enjoyable aspects is the Q&A after the presentation. For 15 or maybe 30 minutes, I field questions on all sorts of topics, ranging from the Higgs boson to black holes to the creation of the universe itself.
Okay, let's engage in some of that discussion, Don. Let's start now, because you told me you won't give me 1 minute, so I'm going to have to put this out into the open public and say, why won't Don give me 1 minute when he's telling everybody he just loves doing this and indoctrinating for 15 to 30 minutes after his initial indoctrination? That's a multiple indoctrination. Ask me anything, I'll just tell you that you have to repeat what I say or you're an idiot. Basically, that's what he says. He told me I'm a tinfoil hat guy. He won't spend 1 minute, and I am out to do the things that he can't do, and Fermilab can't do, and CERN can't do. And I went to the University of Geneva in Switzerland online, but they're right down the street from CERN, and they knew what I was talking about, and they did actually do some of the things that I mentioned, which is focusing and using CMOS. And if I'm not right about that, well, prove that I'm wrong about that too. All right, I know that sounded a little harsh and maybe a little bit arrogant and boastful, but here is the actual evidence. These are Don's particles. I said I found these particles in light. We didn't use protons, we used light. We didn't get just a bunch of debris. We could actually see the particles attached together. One of them glows and one of them doesn't. Exactly what he said. And the black one never changes, and it slams the white one through the venturi. We sped up light, We can slow light down. These are the particles, the muon and electron neutrinos, that turn into the electron showers, which is right here. And again, these are his little pictures, his doodles about muons and muon neutrinos and electron neutrinos, electron showers. There it is. That's fission, that's fusion. They were stuck together before as light particles. They're fused together. So we had to break them apart, which is fission. They had to come back together, which is fusion. And they will always stay stuck together. Instantaneously, they come back together. And this was done with CMOS. Remember how I said I had trouble with Don, obviously, but with University of Geneva as well. When I went there, I said, we're focusing through a Venturi, and we're crushing the fields, which creates these electron showers. And then we're able to see them using CMOS. And immediately I was rebuffed, and no, you can't do that, and you can't see this with CMOS, CMOS would explode and so forth. I said, no. I said, we're working with light. You guys are working with protons. Protons smash each other, and of course you're throwing off huge particles. Yes, that'll damage CMOS. I don't disagree with that. But we're throwing off light, which is what CMOS thrives on. It eats electrons. That's what it does. It eats them. So I said, no, we're seeing it. We can see everything. We can see it with the CMOS. So they listened and they looked at stuff, and I showed them all this stuff, and I said, you have to focus. I said, right now you guys are sending all your particles, 100 billion particles at a time, and they just go past each other, and they're hoping as they go past each other, some of them will hit, and only 25 out of 100 billion. At best, we're hitting. And I said, if you don't focus, obviously the fields are just going to bounce off each other. The fields are, it's called the Kashmir effect, and they are very, very reactive to each other. One will go that way, one will go, but you can't hit them head on. We don't have to hit them head on. We're forcing the black ones to crush them through the Venturi. And that's exactly what's happening here. The black ones are crushers. They crush the white ones. The black ones have all the mass, exactly like Don Lincoln said, and the white ones have no mass and all the burn. And I'm going to show you again in the atomic bomb blast, because that really sets it off. You can't miss. So what have I shown you so far? I've shown you this is what they see. Is a zoo, and they have no idea where any of this stuff comes from, because it's just all in a big pile of debris. Now, I haven't shown you some really cool stuff. This is how I originally got with Don Lincoln. The Russians did this in space. They created this black hole in space. So I'm contacting the Russians, and I copy Don Lincoln in, and I'm saying, these are your charged electron particles. They have extra free electrons. They were going to force dark matter into the center, which it can separate. We could see it separate. I never thought it could, but it can. And it can separate pretty easily. That's why they're seeing all these millions of dark holes everywhere now. They're saying, there's black holes everywhere. Yes, I don't disagree with that. Because the more charged particles you get, they will surround the dark, and they will just continue to grow and grow and grow and grow on top of that dark matter and force the dark particles in the center, and the white will come around outside of it. And there appears to be more dark matter than there is white. It's all I can tell you, because the Earth is basically this. And all of the electrons, all the light, electricity, static, pew, 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 pew. That's what's called grounding. This is ground. This is in space in a vacuum chamber with charged particles, micron sized. And look at where you see what this. When they saw this, they freaked out. They were expecting to see lattices where everybody pushed each other apart equally. No. This is what showed up. One guy locked himself in his room for 3 weeks, the guy at Max Planck. Where do you see what else they found? This is the real killer. And this is what I want to talk to James Tour about. He's supposed to be looking for the origins of life. This showed up. It just congealed in the midst of all of those particles. You know what a DNA double helix is? Well, that's what you're looking at there, my friends. I can't explain it. They can't explain it either. But this was from the Russians, and this was, as they were watching it sort of settle in, it created these DNA strands. And I mean, they have everything. That is as close as you're going to get to DNA. Now, all of our light, I've shown you the speeding up. Now here's where I'm going to show you the atomic bomb. This is the black particles that never change size. They just push or they suck. They're pushers or suckers, one or the other. If they're just sitting there by themselves, they suck all the white particles to them. If they're moving through the air, they push, because they're attached to white particles and everything else has to get out of the way. And it will push the white particles. And that's what it does at the Venturi. It squirts them. It is a squirt gun right here. You see that? When it hits here, the black ones can't get through, only the white. That's white showers. And this is the electron showers are supposed to increase the energy. As you can see, the luminosity is just on steroids. And that luminosity is an increase in energy. That's just exactly what they, if you can tell me that luminosity is not an increase in energy, I want to hear it, Don. I want to hear all of this stuff from Don Lincoln. And then everything has to plow through space. They don't even know these. They're, oh boy, maybe now someday we're going to be able to see gravity fields or gravity, waves. Wow, what is that? All they are is these magnetic push to shove. Anytime you go, it's slowing down. Light slows down absolutely fast. They have no clue where we are in the universe because they think this is just a wide open, nothing there. No, there's nothing out there. Light just comes right through. No, it doesn't. It's pushing against all those other fields, slowing it down, no question. They say, oh, everything's speeding away from us. It's like this light here. If that light is coming from a long way away and it's hitting a bunch of stuff in front of it, it's going to go boom, 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 boom. And it's just going to slow down, slow down, slow down, slow down. And it stretches. That's the redshift. They say the only reason it's stretching is all of the stuff in space is pulling away from us. But that would make us the center of the universe because everywhere you look, it pulls away. All right? Because everywhere you look, light is slowing down. And it slows down fast. Very, very fast. Now, in space, it's not as dense as it is in the air, but you can see what happens in the air, how fast it slows down. That's blue. All right, and we can speed it up too. The red and the green slows down. They all slow down. They all speed up. Doesn't make any difference. And they're all the same particle. That's the particle right there. That's a photon. Here's the neutrinos as they're gaining energy, and then they turn into a photon, and then they explode. The green breaks apart just like the red. And here's the red. Here's the red gaining energy. By the time it hits here, we can really see it. Up in here, you got the same fields. You see these fields? They're coming through here. You can't see them because they're not being concussed through the Venturi. But now they're being concussed backwards. You see how bright they are? You know how much energy radiating backwards that is? That's just off the charts. Because they're here. It's just they don't have any impact yet. This has an impact because it's going forward being sucked for. These are having an impact because they're being pushed back. This is phenomenal stuff. This is off the charts. Fission, fusion, raw electrons. We should be able to harvest energy right there. And this is what we had charged Fermilab to do. And to not look at this, Don Lincoln is not doing his job. That's all I can say. I don't want to get nasty, but I feel a little bit on that side. All right. All right. This is their particle zoo. That's all they can see because they started with those two huge particles. So all they got was trash. And here's what that trash consists of. They call all of these bits and pieces, which I showed you, is all the little trash. The only thing that is this one and this one. There's the white one and the black one. That's it. This one is all the mass and no burn. This is all the burn and no mass. You add them all together, and two of these together makes a gluon. Two gluons make a photon. That's it. The Higgs is when these two come back together. Not the Higgs making these. These two come back together and form a Higgs. That I can show you very, very clearly. All right. When they come through the Venturi and they come out the other side of the Venturi towards us, that's when they create the Higgs, is when the white comes back into the black. That's where Higgs come from. Higgs Higgs are not just always there. They're there when a photon or an electron collides with a muon. And then they turn into these spinning disks. I have a better shots of that. Hold on. All right, here's a shot that's a killer. This is nothing but white. All that is electrons. And every one of them, and there is a bazillion of them. You can't see them because at this point, they're just really rocket ship particles. But see this little particle coming off, and see it hitting the edge of that, spinning into that spinner? Same thing here. They're all coming down, spitting out little white particles, hitting these and spinning them. That's what it looks like to me. That's all I can make of this. And that's when you get these Higgs. And you get these little circular patterns. Now, this is what CERN sees and Fermilab sees. That's all they see. This is it. That's the best they can see. And all they see is trash. Now, they go picking through it and they say, wow, we see a little of these ones and some of these and some of those and da-da-da-da. Why is all the red ones staying so close together? Why didn't they go flying like the blue and so forth? Well, it's because they're not so tightly attached to the nuclear core. And they're using nucleuses. We're not using nucleus. We're using light. We're using light. So we don't have to deal with just trash. We're using light. And light spins. You see this? Light spins just exactly like I'm showing you. It spins just like this. This is a single slit. Some go over this way. Some go over that way. Most of them go through the center. But as they go out, they push each other out. That's why they make these interference patterns. This is a drill bit. You see it? It's screwing down. It's just screwing on down the road. Now, red is way like this. So now we can see the actual drill bit. Green and blue, it's too tight. It's too tight like this. It goes through there, and you can just see a flat strip. But the red, you can actually see as it's screwing through there because it's way out like this. All right. If you look at light as a wave, yeah, that's a wave. But the particle in the front is a particle, and that particle has to push every other particle that it comes in contact with its field. It's the Casimir effect. Look it up. Field to field always creates energy. So this comes out and hits that one. It comes out. All of the particles in front are being concussed, and here's the concussion happening right here. You see it? It's coming forward, and this is where, you got a bunch of little photons here. But they're hitting the fields of all of the particles that are in the room, which are gases, electrons, heat. Excess electrons are heat. That's all they are. Excess white particles are heat. And when you send them through your your copper wires and so forth, what they are doing is sending the white particles down and pushing very, very hard until they get to the black. They want to get to ground. They want to get to the other side of that circuit. In the case of light, the other side of the circuit is ground. All electricity, that's why lightning, if you get in the middle of lightning and you're here and the lightning hits you, it wants to get to ground so bad that you just explode. And the same thing with static, the same thing with electricity, it all wants to go to ground. All right, that's just the nature of particles. Now, there is a stationary particle effect, and then there's a moving particle effect. And then there's heat transferring in and heat transferring out. And all it is the electrons are being taken to a place where they're more receptive, and then they're being sent to a place where they're more receptive. Its heat can move, and all heat is the white particles. I thought this was kind of interesting. What is quantum mechanics really about? It's about money, Don. What is driving particle physics? Money. Here's Sabine Hoffensfelder. Finally, she's coming around. What's going wrong in particle physics? This is why I lost faith in science. And yeah, you have to lose faith in science because all it is dogma at this point. You see this? Particle physics attempts to answer timeless questions first asked thousands of years ago. Well, I'm trying to answer them too. He's showing the tablets from the Sumerians. Don, like he said, I give all kinds of. He gives them one right after the other, but they're all the same stuff. It's just nothing more than forced dogma to say, here's what it is and here's how it works. Boom, 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 boom. Particle detector subatomic bomb squad. Well, I'll show you some subatomic bomb squad. Okay, I'm going to show you a subatomic bomb. You see this right here? That's the cross section of a subatomic bomb. This is all the white particles which would completely coat this inner, because think of this as all being black particles, and all of these are being the colored light that comes off of bright white. Consists of all the different colors. So this is all the colors wrapped around a black ball. Okay, the black ball is the nuclear core. What will happen when it blows up, they force all these things in, because already they want to fall apart. It's fissionable material. It just wants to fall apart. There's many too many particles in this space. They don't want to be there. So they're ready to, and then they crush them together. And what happens is, the first thing that happens is all the white, almost all the white, will take off. And it'll just spread out as a vapor going forward. Then the black shoots out right behind it as a wave right behind it, pushing the white particles. Let me show you that, and then I will show you precisely what happens inside a nuclear bomb explosion. First, the white will burn the house, not even move it. Then the black will hit the house and just go make it fly. Let's watch that. Well, let's watch this first. Let's make sure you understand what you are going to see is this. That's where the bomb goes off. All right, so don't forget, here's your black core. Here's your white stuff right there. This takes off. All the white takes off. It's stuck. All the white takes off ahead of the black, but the black is attached to it, pushing it. You see this? So the black pushes the white just folds around like this and makes a wave going forward, and the black is right behind it. It just spreads out like that instead of a ball. I can't really spread it out, but that's what happens. It spreads like that and just pushes the white forward. The house is going to be here. It's going to burn, and then the black will hit it and it'll go flying, because these babies are powerful. These have no mass whatsoever. They have all the energy. These have all the mass and no radiating energy, no glow. All right, so here goes the house. All right, first thing you're going to see is the brilliant white flash. All the white particles are coming forward, and they're hitting everything in the air. Everything there is absorbing. There's nothing that's going anywhere. You see that? There's no movement whatsoever. Zero. It's just, it has no mass. That's why when you charge your battery, you got all that energy in your battery, a ton of energy, no more weight. Almost no weight whatsoever when you charge up a battery. But look at the energy that's coming out. Now watch. All of a sudden the black will come and the house goes flying. Pow. Here it comes. Boom. You see that? And now it's not burning anymore. It's just flying, and that's the black that, whoops, has come behind the white. All right, that's all it is. Now everything will turn around and come back to try, because the black, there's still more black back in the beginning, so it'll turn around and come back, and here's that's happening. All right, it's going out. Now watch, it's going to slow down, and here it comes back. All right, so that's, it's pretty obvious there's a void back there, so a vacancy of some sort, and I believe it's the dark particles. There's still a bunch of them still back there, and it's pulling it back. You see, this just came out, April 5th, 2023. Universe isn't empty, it's filled with the quantum foam. They've known about this for a long time, just disregard it. Well, now I think they're coming around and realizing we better step up and say something. This Fermilab is not doing their job. Okay, they always refer to Einstein. I'm sorry, Einstein was just not right basically about anything. It has nothing to do with space and time. Time is is relative to where you are when something happens. That's all. You're going to see something, minutes after it happened. If it was out in space, yes. That's just the time passing as the light comes. It has nothing to do with time invariant and all that nonsense. And light speeds up and slows down. There's no question whatsoever. I've shown that. So Einstein, we know now, was incorrect.
Distance and time have to be relative to the observer. They have to shift to keep the speed of light the same for everyone. This same axiom is also fundamental to general relativity, in which gravity is interpreted as a warping of the fabric of space-time.
All right, so we know none of that stuff is correct. Light slows down, it speeds up. The warping of space-time has nothing to do with it. It's the slowing down of light, basically, which changes its frequency and changes its color, shifting more to the red as it goes through all the particles it encounters, the quantum foam. So,
special and general relativity have been tested with extreme care and precision over and over and have never failed.
No, that's not true. They failed every single time. It's just that nobody will take a look at the failures. If you don't examine things, and I've been after this guy here for years now, and I'm hoping maybe he's taking this into account, because what if it isn't constant? And it isn't, we know that. But it looks like he's still defending it. I haven't watched this, so you're watching it with me. This is what research is all about.
More to the point, the speed of light has been measured in different reference frames, and its invariance holds down to the exquisite precision of current methods.
That's ridiculous. I can show you. They already know this now. Just recently, they did some tests on the speed of light. It slows down, obviously, in other mediums. We know that anyway. And it doesn't speed back up again all by itself. It stays slowed down.
That said, we scientists are supposed to remain simultaneously skeptical and open-minded, somehow applying both mindsets to both old and new theories. So, in that spirit, let's ask whether the speed of light is really invariant. For example, could it change over time or be different in different parts of the universe? There are some who believe that the very effects that relativity predicts are due to the speed of light changing, not due to changes in space and time themselves.
Yes, that would be me, Roger Spur.
Now, before I start talking about what it means for the speed of light to change, I want to make it clear why many and perhaps most physicists think that it's not only impossible, but it's not even meaningful to think about a variable speed of light.
What do you mean not meaningful? We're saying this star out here is 750 billion light years away because light never changes its speed. That could be right down the street. If it's coming through this really dense stuff, that's going to slow down. I've just shown this. So what does it mean? It's not just silliness.
The speed of light isn't really about light. It's the speed of any massless particle, and also the...
Light is not massless. Light contains the muon and the electron neutrino, and I showed you light coming from an atomic bomb blast. It sure as hell is not massless.
Maximum speed that information can travel. It's the speed of causality. It's the rate at which one point in space can communicate with its neighbors, assuming no impediments. So to change the speed of light, we need to change something pretty fundamental about the universe, the connection between space and time. We measure...
See, this is where you go, because Einstein said time slows down or something. I don't know. All this nonsense about warp space and so forth. Space warps because it's being pushed against field.
Speed in terms of the amount of distance traveled per unit of time, whether that's miles per hour or meters per second. Changing the speed of light means changing the number of meters it can travel every second. The problem with this is that our very definition of meters and of seconds are tied to the speed of light. We can think of the meter as the distance light travels in 1/300 million seconds, or we can think of the second as how long it takes light to travel 300 million meters. Einstein said that time is what clocks measure, which we can interpret as meaning that time is a measure of the rate of change of the universe. One of Einstein's thought experiments was the photon clock, in which he imagined a photon bouncing between two mirrors, and each two-way trip indicates a tick of the clock. So what happens if we slow the speed of light? The clock ticks more slowly, which means time slows.
That's ridiculous. That's just absolutely ridiculous. Time doesn't slow down. The light particle slows down. It's amazing. Does time slow down when a car speeds up? Oh, man.
Now, real clocks are made of gears or electronics, which are made of atoms, which are made of various quantum oscillations bound up in ways analogous to the photon clock, whether electrons communicating virtual photons with a nucleus or quarks exchanging gluons in that nucleus. This argument applies for any object with mass. The speed of light dictates the rate of internal change, which determines the rate of the flow of time for all matter.
No. It has nothing to do with time. Time is a constant that just progresses wherever you are in your local region. It has nothing to do with anybody else's time. If they had binoculars and real high-powered telescopes and could see you, 1,000 miles away, yes, it's going to take an instant for that light to go that 1,000 miles to get to your eyeball, yes. There's no question, but it's going to slow down in certain mediums. So it has nothing to do with time. It's because it's slower down there. No, you're just looking back in time a zillionth of a second and seeing what happened when that light was produced. So if you want to tie that to time, good for you. It has nothing to do with the speed of light and time. The speed of light speeds up, it slows down, time just ticks and ticks and ticks. Now, they did some space experiments with atomic clocks out in space. Well, you may be able to get it to change because you don't have that gravitational influence anymore. You don't have that on Earth where you would have it, where they're checking it, how fast it's going, and they're checking it out there. They're seeing a difference, I think. All right, let's just continue on. I want to get this out of the way. This has to be taken care of. We can get free energy right now if we can get these people to pay attention. And I have shown so much evidence to support that we need to look at this. It's very, very discouraging to go for 8 years trying to work with the top physicists in the world and having them just laugh at you, literally laugh at you when you present evidence that totally crushes what they're showing.
So, if slowing light also slows time, would we even notice? Not according to special relativity, in which space and time are fundamentally coupled, two sides of the same coin. Changing the speed of light slows time, and moving the mirrors further apart also slows time. In this picture, distance, time, and the speed of light scale together. So on our scale, there's no observable effect. The speed of light is just the unit conversion factor between our arbitrary choices of spatial and temporal units. The only way for a change in the speed of light to do anything is if time and space both have their own fundamental units that are independent of each other. If there's...
Yes, they obviously are. Light has nothing to do with time. It's just that when you're looking at something that happened 10 minutes ago out in outer space, it just happened 10 minutes ago. That has nothing to do with your time.
A basic smallest unit of space and a smallest unit of time, and these don't depend on each other, then maybe changing the speed of light would change the relationship between space and time, at least on the quantum scale. So let's imagine this is possible and explore the consequences. The first real variable speed of light, or VSL theory, was proposed by Robert Dicke back in 1957. Dicke was a brilliant physicist and astronomer with wide-ranging contributions, so we should at least pay attention to his musings. Dicke wondered if gravitational fields might not be due to the bending of space-time, but instead due to the speed of light slowing down near massive objects.
He's exactly correct. His musings.
Remember that light changes its direction as it moves into a medium where its speed is lower. That's exactly how lenses work. So why not gravity too? And we know that time does tick slower in a gravitational field. And we now know that slowing the speed of light should slow time.
Time doesn't tick slower in a gravitational field. We don't know these things. They always, we know this. No, we don't know that.
It seems like a variable speed of light could be an elegant alternative hypothesis, no?
No, it's not a hypothesis. It's an absolute fact.
No. Back in 1957, there were only a few successful tests of general relativity, and some of those were consistent with either space-time curvature or a changing speed of light. But nowadays, we know that space-time itself must be dynamic. We've measured how rotating masses drag space around and how colliding black holes generate gravitational waves, none of which work with the variable speed of light interpretation.
No, incorrect. They all work with the variable speed.
Dickey's idea was intriguing, but it doesn't stand up to the latest evidence.
No, it stands up to my latest evidence. You won't stand up to my latest evidence. You won't stand up. That's the problem.
And given that evidence, Dickey himself would surely agree.
No, he
so
wouldn't.
maybe a variable speed of light doesn't explain all of gravity, but could it still play a part? There's one weird fact about our universe that could possibly be explained by this idea. If we look at the edge of the observable universe, in that direction, we see a warm, smooth gas that existed before any stars or galaxies formed. We see exactly the same in that direction, or that, or that. The universe at early times was extremely homogeneous.
All it means is that the light coming to us is starting to slow down in every direction. So that doesn't mean we're the center of the universe because everything's pulling away from us. That's what they would say. We are not the center of the universe. We are just part of the universe, and light is coming, going in all different ways. But what they're looking at, the cosmic microwave background, is just all the light that's just slowed down to almost where it's just stationary in space. They become electrons just laying around in space. And there's going to be warm areas in space, and there's going to be cold areas in space. And the warm areas are going to be loaded with extra electrons, and the cold areas are just not going to have the electrons. But they're going to be in that very, very long frequency microwave range where they're not really lit up. They call it the background because they just slowed down so many years ago. They're just laying around now. So it's a homogeneous. So anyway, they're talking about the early universe. No, that's the universe now. It is homogeneous because so many of the light particles have slowed down to just being virtually laying around in space, just doing nothing. Now, I don't know where the universe came from. Nobody does. I can tell you that. Nobody has an idea.
It's the same density and temperature everywhere. That tells us that at some point in that distant past, all of that material had to have been in contact in order to distribute energy and settle into the same state.
No. All light slows down until it just no longer has enough energy to really push forward. That's why it's all back in the same state.
But the problem is, based on the observed rate of expansion of the universe, there just wasn't enough time since the Big Bang.
The observed expansion of the universe, and they are judging the expansion of the universe on the speed of light as it's shifting red coming to us. No, it's not the universe expanding, it's light slowing down. So there's just another misconception.
For those regions to have communicated with each other. We've talked about this so-called horizon problem previously, along with the mainstream solution of cosmic inflation. Inflation hypothesizes that at some very early time, those distant regions were in causal contact with each other, enabling them to share energy at regular light speed and reach the same temperature. But then, the universe underwent a period of extremely rapid expansion, much faster than the speed of light.
The speed of light you can't exceed the speed of light. This is just insane. They can make up anything they want to say to justify the nonsense that they're saying. It's really, really discouraging. Okay, let's continue the foray. So now, everything's going much faster than the speed of light. Came from who knows where, nowhere, obviously. The Big Bang, no, I don't know where it came from, but I'll tell you what, when I look at the ancient stories of the universe, I can accept those much easier than I can accept this kind of nonsense.
before slowing dramatically. This threw apart regions that were once close enough to be in thermal equilibrium so far apart that it appears now that they could never have been. But there is another way to bring those distant points into causal contact, and that's by having light move faster in the past. This could have kept the early universe connected as it expanded and reached uniformity. Then, if light slowed down to the current much slower speed, distant regions would seem causally disconnected. And if this story is right, it could even be that the speed of light has been gently decreasing ever since.
Exactly. Anytime light is created, it's an extreme movement of a particle. And it interacts with all of the other fields in front of it, and it slows it down, that movement of that field particle. Because light is a field particle. It's a field. That field has to push through every other field. And fields are everywhere. And when I'm talking about everywhere, I mean everywhere. Let's just prove that, and we'll go on with my friend here. Hold on. Where are fields? Well, fields appear to be everywhere. You see those lines? Those are fields. You know what a magnetic field is. And that's why light slows down. And this is just right local here. This is slowing down very fast, right down the street from us. This is not way off in space. This is the moon, and whatever this is that's giving off this huge field, this is not the moon giving it off. This is something behind here, which is probably a planet or whatever. Or it could even be the sun. I don't know. But whatever it is giving off enormous amounts of particle energy that are concussing as they go forward, and they're slowing down. So literally, on what they're talking about, stuff being hundreds of billions of light years away, I mean, it's just insanity. It could be literally just right down the street. No idea whatsoever. It's saturated with particles, and so stuff that's coming out of here and stuff that's coming out of here, they're obviously from different speeds. One of them has to come through all that stuff. All right, so what do we know now? Really nothing. We know the light speeds up. No question about that. We know that the particle is made up of the black and white particles, which we've seen. Fermilab and CERN's seen them too. We divided them. That's fission. Here's fusion. This is raw electrons, has no weight, but all the energy. The black particles have all the mass and no, field energy to speak of. They push the white ahead of it. They're just like pushers. And when they're just laying around, they're suckers. The white will come to them and collect around them, just like the Russians showed in space, which I did show to Fermilab and said, we got to start looking at this stuff. Nope, not from you. Everybody else will take any kind of questions, but Roger, nope, not 1 minute will we spend with him. Too much information. Information overload. Fermi is on critical information overload. Well, I don't like spending billions and billions and billions and billions and billions of dollars decade after decade to fund these people to walk around in circles and not pay attention to what is right in front of their faces. Just not right, my friends. Just not right. So let's go back to our friends here at PBS Space and see what other nonsense he can come up with to cover their tracks. Okay, so back to PBS.
Could explain why many galaxies appear to be accelerating away from us. Since light is supposedly becoming slower, it's taking longer and longer for their light to reach us, giving the appearance that they are accelerating away from us. That may sound good, but variable speed of light theories don't have a good explanation for why light speed would change in the very particular way needed to mimic both inflation and dark energy.
I just showed you that. There's no question. I showed you that the things increase in speed, slow down, and they have the dark energy, the dark matter, and all of the things you're asking about. It's just an assumption on your part. Let's go back to here. I don't want you to miss this. All right, let's make sure we understand each other. He's saying that Yes, everything looks right. Everything looks right. Acceleration away from us, since light is supposedly, listen to what it says here.
Supposedly becoming slower, it's taking longer and longer for their light to reach us, giving the appearance that they are accelerating away from us.
Exactly. That's what the redshift is. They're not accelerating. The light is slowing down. Just exactly what he said.
That may sound good, but variable speed of light theories don't have a good explanation for why light speed would change in the very particular way needed to mimic both inflation and dark energy.
All right, let's talk about that. Think about what he just said. We need to be able to mimic inflation. Who says it's inflating? And dark energy. Well, the dark energy I've shown you, the inflation, I don't know if the universe is inflating. Why would he say that?
Cosmic inflation seems a little cleaner and is certainly better accepted.
They accept it, but it's not, who's to say it's right? Cosmic inflation seems cleaner. No, it doesn't. Light slowing down seems much cleaner than everything that's expanding away from us and we're the center of the universe.
First effort to explain the horizon problem with a variable speed of light theory was by John Moffat in 1992. He proposed that the speed of light may have been 10 to the power of 30 meters per second in the early universe. Moffat lays out some substantial theoretical work involving symmetry breaking, analogous to the one that separated the electromagnetic and weak forces, but in this case the broken symmetry was Lorentz invariance. Moffat's theory preserved Lorentz invariance on relatively small scales like across the galaxy, but allowed it to vary over cosmological distances and times. Another similar idea came from Andreas Albrecht and João Magejo, and yet another VSL model depends on the energy of light. Higher energy photons would move faster. Perhaps then the ultra-high energy photons near the Big Bang did travel fast enough to connect distant points of the universe. Then as the universe cooled, those high energy photons became rare, and so light slowed down. Now, we have absolutely never observed speed differences for lights of different energies at any energy that we've detected. And that...
No, that's wrong. Absolutely incorrect. I'll show you that right now. You see that? That's right there. Both particles going through the same slit at the same time. The red is much slower than the green, much less reactive, much less concussive. The green is extremely high powered, and it pushes the red right out of the way. Just get the hell out of the way, and it reconcusses out here. So it's obviously much more powerful. And here's the particle. It's the green, the same as the one that Rod and Warren was finding. And Rod did almost all of the light research, almost all of these pictures. Some I did and some were done by other people. But Rod did like this here. I mean, look at that. That's the black pushing the white. And that's what burnt that house down. And the black knocked it over. And light spins, quite obviously. That's a spinner, and all of these interference patterns are interference because of magnetic push, not because of overlapping waves. That's a single slit. And we can show the neutrinos building till they create photons, and then they explode, creating the muons electron showers, which is precisely what they want to do at CERN and Fermilab, and we have done it with light. We don't need protons. They want to make these huge machines for billions and billions and billions and billions of our dollars and have never gotten anywhere. They have just barely achieved break even, which means the amount of energy they put in, they were able to get back. So that's just like charging up a battery and getting it back. They did nothing. We increased the energy value exponentially. If you can go from electrons to electron showers, it goes into the trillions of electron volts. And we started with a very small amount of electron volts, millions tops, and ended up with billions or trillions. That's energy increase that can be harvested as the fluffy white energy that has no mass and just fills up the energy with electron pores. And then you can suck that right out of there to do anything you want, or just run it right out of here. because this is a never-ending process. We don't have to stop this laser. Why stop the laser? What they're doing, this is it. It's just continuous. It's just there. We harvest it here, and then that's the end of the story. And then it goes down into a regulator. First of all, it's got to go through a photodiode of some sort, which it goes through and it can't come back out. And it's just that fluffy white stuff. It charges all up, and it's just so desperately wants to get back to the black. When you feed it through a wire, it will find its way back to the black very strongly. Electric motors are very, very powerful. Electric cars, they rocket ships. Electricity is, it explodes you if it hits you. And it wants to get to ground, and this is ground. These are the particles. And this is really interesting. This goes back to 2015. And this is when I tried to contact Don Lincoln about this at Fermilab, and I was really, really nastily rebuffed. I lost total respect for, and, we're paying them. This is not like they're doing it for free. They're using your tax money. We're paying billions and billions of dollars, and we're fighting for every dollar. And they're teaching the kids something that isn't true, because this is light speeds up, slows down. There's just no question about this stuff anymore. To deny this is really a travesty against knowledge. It's really disgraceful at this point, because this has been going on for 8 years now. As a matter of fact, we're starting to write new books right now. Electron flood theory. Ether particle theory. This ether particles were known in ancient times. He said it's ether. Ether out there is in the space. But now it's all theory. It's all equations. It's all Einstein. Einstein made these laws. You got to go by that law, or you're an idiot. No, you're an idiot if you go by the law, seeing what I showed you. And then you can just say, oh, no. We can't talk to that guy because he doesn't have a PhD. Well, I'm not perfectly happy deluded. I am a material scientist. I present evidence, and if you can't see that evidence, that is your issue, not mine. All right, let me just explain two things to you. One is the cosmic microwave background. This is very, very, very slow light, just barely moving along, sort of bouncing around out there. No big deal whatsoever. Way down in the energy levels. Now, and these are the frequencies, very slow frequency. Then you start to get up higher and higher and higher and higher, and then you get into the visible light frequencies, just in this one range here. This is the only range we can see with our light, with our eyes. Then you get an ultraviolet, which, of course, the heat is down to infrared. Microwaves is a pulsating energy, which actually heats up water. It's in that frequency that is resonant to water. Now, above that, you get infrared, and that heats up just about anything when it hits it. Visible is where we can see these frequencies with our eyes. Then you get into ultraviolet, and that's a damaging ray. That should, well, it does cause skin cancer, too much ultraviolet. Then you get above ultraviolet, they call it the ultraviolet catastrophe, because after ultraviolet, there's no more emissions of electrons. All you got is the real bangers, X-rays and gamma rays. Those will kill you. Gamma rays are what they use to destroy tumors, to kill tumors. And what's the difference? Well, at this certain temperature, the first thing the red gives off, then the orange, then the yellow, then the blue, and then the purple, and then there's no more give off. There's no more electrons emitted because there's no electrons left. Once you're at the very bottom of the level of electrons, it's all gone. Now all you got is the nucleus. It won't give them up. So that's all you got is the nucleus, the black particles. And that's why when they spit out at these, those will kill you. Those are the things that knock houses down and smash tumors to bits. All right, before I go any further, I just want you to understand, Rod Warren took all of those pictures that I'm showing you, basically, almost 99% of them. I took some, Dylan took some, Fabian took some, but Rod was the major, and he was the one that started this whole thing by coming up with this Venturi concept. Just by accident, but what he was doing was looking to see, is there any life in light? You always hear, let there be light, and then there was life. Light is what makes plants grow. Well, why? Is it just the energy? I don't know. I always said, well, it's just the energy, so I sort of disregarded his idea that there might be something to do with life inside of light. Well, guess what? This is what we just saw. That happened in space just from having particles in space, which are light particles. They're light. And light is atomic vapor. I did this paper, I had, years and years and years, 1970, 71, somewhere around there. And I ended up with saying that the transfer of energy is from light to atomic vapor. This is atomic vapor, which is light. And now it's turning into DNA, it looks like to me. So I apologize to Rod for never giving any real big credence to the fact that something could spontaneously combust into life. I don't know if that's what's happening there now, but sure looks like something's going on that indicates life to me. So, but I'm the atomic guy. He was different. All right, so that's why, and I did this, I went as deep as you could go with everything, into chemistry and all the thermodynamics and everything that was known at the time, and everything was polarities, dipole moments. Everything was based in push to shove, and there was no such thing as one gigantic big positive and little tiny negatives. They just slapped like this. I said, you guys are crazy. It's impossible. Oh, no. Einstein proved this. Heisenberg proved this. Rutherford proved that. I said, no. And I showed every one of them. I went against every one of them head to head, and I pretty much showed that they just weren't right. You had to be dipoles. So that's my dipole electron flood theory, and which means that everything there is composed of the black and white particles. So anyway, again, Rod Warren was the one that came up with the Venturi, and then so graciously worked with me for 5, 6, 7 years, and he's sort of backed off of it, and I can understand how frustrating it must be over that course of time to just get nothing out of it, really, not be recognized for what he's doing. And I recognize him, I'll tell you what, and the world will at some point. And I thank you deeply from the bottom of my heart, Rod, wherever you may be, brother. And by the way, this came from Rod's nephew, Dylan Carpenter, who took this he sent me a bunch of pictures of fields in space, and I'm not sure how he did it. I haven't heard from Dylan either. People sort of back off of this stuff. I understand it. Not many people are interested, it seems. But all of this is material evidence. I'm a material evidence guy. I don't make all these claims without any evidence to support it. And, I'm taking the particles that they saw, CERN, Fermilab, Lawrence Livermore, JPL, all of them, and there they are. We didn't start with protons, so we didn't have to dig through all the debris. This is the debris they have to dig through. There's nothing here but just chunks of little this and that. And all the red sort of stays because it's just not held so tightly as the blue and down real tight. When they go, they have to really be pulled away, and they just never come back. The reds just sort of bounce around out there, and that's why they see that pattern. Because they're working with the complete spectrum, all right? So they're working with all the different ranges of energies because they're just smashing things together. We have what it's called a coherent beam of energy. So we have the red. All right, now I'm not sure. Hold on a second. All right, just so you know, these are the different frequencies. Red is a long frequency. Hold on, let me show you my little thing. Red is going to be like this. All right, then you get up to green. When we're working with these coherent focused beams, we're somewhere in this red range. then you have green, and then you have blue. Now, the red is like this, the green is like this, and the blue is like this. It's a sizzler. And the green is like this, but it's pretty hot still. And the red is sort of works its way through, sort of rolling past. But these are the different frequencies. And the different frequencies correspond to different energy levels. And I can only turn on an LED, which is nothing more than a light emitting diode. You can turn those on backwards, but I can only do it with the blue. The green and the red don't have enough energy. This is energy. So the tighter the frequency, the more energy. Violet is even more energy than that. And then at that point, all the electrons are gone. And then you go into the ultraviolet catastrophe, which says there's no more electrons, so throw off the big chunks. That's when that stuff kills you. All right, so let's see what they have to say about gravity waves and all that. I showed you Dylan's pictures of the gravity waves. So we're back to PBS, and here we go.
Materials don't behave like this. Still, it is a sort of way out. And there are some other narrow paths through the dense network of refutations of BSL theories. However, you need to be pretty committed to these ideas to find these ways out. Currently, there is no evidence that the speed of light varies in a fundamental way.
I just showed you that, so yes, there is. So that's an incorrect statement.
And it may be that it's not even a meaningful concept. Although that latter point depends on an understanding of the quantum nature of space and time and their relationship to each other that we don't yet have. It's absolutely worth going back and questioning the founding axioms of even our most successful theories.
Exactly. And please, somebody's got to contact these people, because nobody contacts me back, because as soon as they Google me, it says the guy's crazy. And I'm presenting evidence, but I have been peer-reviewed out of existence. So,
as long as we keep in mind that any new theory is going to have to do just as well or better than the old one in all of its predictions. And that's a tall order when you're trying to break relativity, which has such deep internal consistency and is so powerfully predictive.
All right, I'm going to just leave it at this, but you can come up and look at this. I think I have made my case spectacularly, in my humble opinion. Take it for what you see, but if you want to just follow these people and think that space is completely a vacuum, and see the evidence that completely shows it's just ridiculous. And light obviously is going to slow down coming through there. The Hubble, Webb, all of that, nice little toys. But look at this. This was done with a cell phone. And so was all the rest of this. All of these pictures here that Rod took was done with the cell phone. I have one right here, the same one. It's the Samsung Galaxy S3. Hold on. Anyway, I got it around here somewhere, but I got all the same stuff he had. Hold on. All right, here's what we used. And I did some of this, but again, Rod was the guy. It was a Samsung Galaxy S3. This goes from 2014. And he used the selfie side and was taking pictures right into the beams. Now, I did something different. I used screens. I don't have the patience for this. He somehow, he took two finishing nails. The first time I saw him, I got a hold of him right away, because I knew what he had. I said, you accelerated light. I said, how did you do that? This was the one I saw. And he said, I made a single slit, or I made a slit. He was trying to do double slit. And so I had him explain to me what he did. And all he did was take two finishing nails, just like that, side by side, very close, and shot the laser through it. I believe in a totally dark room, and the laser's shooting like this, boop, 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 through there. And he's taking the selfie side right down here. And he's seeing this stuff come out. That's how I understood what he was doing. I never had a lot of success at it. He's an absolute master, but he spent years and years doing it. And here's what the result was. Now this one here is raw white. There is nothing but white, zero other than white. So here's another one he did pretty recently that I saw. And now you have some black and white. So you can see the black is pushing the white, and that's when I showed you the house burning down. And there's no mass, all energy. And this is the dark matter. The dark matter pushes the white matter. We never realized that before. Nobody's ever seen the dark matter before. And again, Rod could be onto something. There could be something going on with this life. That I can't really comment. I have no idea. I'm a physical guy. I see that we've overturned everything there is in physics right now. And in addition to that, this has to be completely changed as well. And I know what I have to do to it to change it. But it already is changed. Nobody even knows about it. People say, elements have isotopes. Well, what is an isotope? An isotope just means, like copper doesn't have just copper as one weighs a pound, you know. This is hard to explain. Isotopes just means the same element but bigger or smaller. It'd be the same element, but they could have all kinds of isotopes, and they have half-lives. They say it's still this copper, but it's way down here, and then it can get stabler and stabler and stabler until it hits a stable where it's supposed to be. Then they can get more and more and more electrons, and it's still copper. So there's nothing but zones of stability. Think of it that way. All right, zones of stability these are. But there is a zillion different changes in between them that are unstable, but are transition stages, which our enzymes take advantage of those to nucleophilically transition all kinds of elements in our body to make the chemistry to make our body work. And that's a whole nother level of chemistry in the biology realm. And that's how just these simple basic elements can create life. They can all kind of mingle like crazy so fast it's unbelievable. That's why they don't know how many particles there are here. Because all they can see is certain ones that have a certain duration of time that they're stable. And the duration of time I'm talking about is faster than electricity moves. So they don't know how many particles there are here. I know they got a little complicated, but this all has to change. There's a lot to it that's correct, but like hydrogen is not one proton, one electron. It's about 1,825 or so dipoles. All right, so that's a pretty significant change. Okay, now they say in special and general relativity, undefeated champion. Well, that's good. That's Einstein. Now, let's continue on here and see. There's a comment section. Here we go. So keep in mind that any new theory is going to have to do just that, which is overturn Einstein with evidence, which I believe I did.
Well, or better than the old one in all of its predictions. And that's a tall order when you're trying to break relativity, which has such deep internal consistency and is so powerfully predictive. But relativity is not the final theory due to its clash with quantum mechanics, so let's keep questioning it, including whether the cosmic speed limit is fixed, or we can somehow change how fast information travels through space-time. So we missed a few comment responses recently.
I commented many times, and they're saying they missed a few, and this is hopefully they won't miss this one.
Actually, we missed 6. It's my fault. There's been a lot going on, including too much travel, And these responses actually take a lot of thought on account of your really, really good questions. So today, we're going to go back and do responses for a selection of the missed episodes. We'll catch up further on future episodes. We'll do one comment from each of these, but we're going to do each of those very fully, and we'll also do them completely out of order. We have the episode on superfluids, then the one about turning the sun into a spaceship, and the one about detecting planet-sized spaceships using LIGO, and finally the one about how terrible or awesome the next nearby supernova is likely to be.
How about the speed of light? Is it consistent or not? They're going to comment on those kind of things. Let's see if anything makes any sense to the comments. I'll see if I find something. Hold on. Okay, he said he missed 6 comments. Well, I've been commenting over and over. Please take a look at my information. So I'd like my comment addressed, please. And again, I can be respectful, but I've been ignored for so long that it's hard to keep respect for people that are making all these statements and claiming all these claims. All right, so I'm going to try to post this up here as a comment. And see, we appreciate any time you take to respond to comments. I don't know if that's true or not. I enjoy the fantastic reason given by Matt doesn't do comment responses. Well, I hadn't had any responses. So anyway, let's see what happens.